Save us all. What? Psych. Come on. You know you've done something wrong. All right, are we ready for the next one? So the answer to this is 1 over 156, right? So it takes not hardly any time at all, right? 6.41 milliseconds to go up and down, right? That's why you can't see guitar strings moving, because they're like the blades of a fan. All right, next one. Next one. A simple harmonic oscillator, don't be calling somebody a show, okay? Has a period of 0.225 seconds, so what is its frequency? How frequently does it go up and down? How many cycles per second is that? Is that the same formula? Yeah, that's right. All right. There's some dodgy characters in this classroom. That is correct. I just got to find the right dodgy character to give this one to. That's right. Yep. 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 Yeah, you got it. Yeah. Do you skip a class? No. That's why your name's not on here. That's right. Have you been bad? That's right. Yes. I get 10 times that much. That's right. That's right. That's right. Yes. Yes. Figure out why that happened. Yes, yes, yes.
Why what happened?
There should be a decimal point right there. Is there? Is that 4.44? I love that. Yes. Yes. That's right. That's right. Yes. Only it's hertz. This one is cycles per second, right? All right. Are we ready for the hard problems? A mass on the end of a spring oscillates with a period of 2.252 seconds and an amplitude of 0.450 meters. What is its maximum velocity? Save this value because this is like a string of questions. How do we find the maximum velocity? Well, the only formula we are given really to do this is this formula right here. Now, we must understand simple harmonic motion and understand that the amplitude is x naught and that is 0.45, right? Omega we can figure out, that's 2 pi over the period I give you. What do we put in for the displacement to get the maximum velocity? Zero at the origin when it crosses the middle, right? Equilibrium position is its maximum velocity. So this breaks down, boils down to, reduces to omega times x. That's the not given formula. There we go.
What is W again? Angular velocity.
Angular velocity, that's your 2 pi over t. So this has how many steps? 2 steps. Find omega, use this formula. And then store this thing, either write the number down. If you don't know how to store a value in your calculator, write it down with like 5 sig figs. Or you can just go storage alpha A. And then when you type A again, it'll barf that number up again. Yes. Yeah, I get the last digit as a 2, but I still love you deeply. Not in a bad way. Yes?
Did you get the wrong answer for the round?
Yes. What units does that have? It's velocity. Yeah. Is that meters per second? Yeah. That's beautiful.
Do our calculators have omega?
Is that a 1, 2 in the last 2 digits?
Yeah.
1.12, I love that. Yes. 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 Right, so you're going to go 2 times pi. Yes. 2 times pi divided by 2.52 times 0.45. And I'm going to store that in alpha A. One swell foop. All right.
What is angular? What's the, what do you call it?
The symbol is called omega. Isn't that great? That's right.
Meters per second. Or
Radians per second is what it is. That's right. When multiplied by meters becomes meters per second. That's right. Yeah, you got it. Yes. Yeah. Let's see. What is its maximum value? I get 1.12. Yes, that's right. Yes.
Is it radians per second? Meters per second.
Well, remember, radians aren't really a unit at all. So it's radians times meters per second. They're just really meters per second, right? That's right. Remember, a radian is, if you've got a circle, that's a pretty good circle, right? There's a distance here, and there's a radius, right? This angle here is defined as S over R. That's in meters, that's in meters, so it has no units.
it has units. Except the unit it has.
Has everybody saved the number, the value? All right, are we ready for the next one? All right. Did we get it right? Yeah, we did. Look at that. Okay. A mass on the end of a spring oscillates, blah, blah, blah. Write an equation for its position and an equation for its velocity. Let's pick this family of equations, shall we? Right? Let's assume that it starts at the middle going upward. It should say that on the sheet, right? Starts in the middle going upward. So we're going to use this family of equations as opposed to this one, right? Which is, starts at the top and goes down. Yeah? Or starts at the right side going left. So what are you going to do? Well, what's the amplitude? X is the amplitude. Instead of X, you're going to write 0.45. And instead of W, you're going to write what it is. Yeah? And T, you're just going to leave T, right? .52, I don't, oh, A, I see A is your, and then T is T, not big T. Just leave it as a T. So what's omega? Don't you have to figure out omega? Don't you have to figure out omega? Omega is 2 times pi divided by 2.52. We need that as well, right? Then what is this, 2.49? Yeah. This is one of the most powerful things you can do is just look at you go from an equation to knowing what the quantity is, or going from the quantity to what the equation is. Is that right? 2.49, there we go, that's right. Except your bottom one's not right, I don't think. Yeah, you gotta use your maximum velocity. Did you? I'm not sure you did. No. And then our V is, what was our maximum velocity? 1.12, right? Right. Now obviously you would use more digits than that. You'd store it in some location, the omega, whatever it is, right? Okay, you'd store it in there. But here are our equations. X naught is just given to you. You have to figure out V naught, but we did that in the last problem. The maximum velocity is what you put in there, right? Omega, to figure out omega, notice that once you figure out omega, these guys are the same, right? And omega, I just figured out that's 2 pi over 2.52. Yeah? Okay. That's not so bad, is it? And T is just time. We could plug in any time we wanted and we'd get, right? So this is, yeah.